Hi everyone, I will present our project which focuses on the application of Geographic Information System or GIS in analyzing consumption data in Malaysia. Geographic Information System or GIS is a technology used to manage, analyze, and visualize spatial data. It allows us to understand patterns, relationships, and trends that are otherwise difficult to detect. For this project, we use QGIS version 3.44.5 as our primary desktop GIS tool. QGIS is an open-source platform that provides powerful tools for spatial analysis, data visualization, and map production. In addition, we utilize the QGIS to Web plugin, which enables us to convert GIS outputs into interactive web-based maps. These plugins make it easier to share our results and allows users to interact with the data directly through a web browser. The study focused on consumption data in Malaysia, covering a period from 2018 to 2022. Each member of our group analyzed data from a different year, which allows us to observe temporal trends and compare changes over time. Using GIS, we are able to identify the spatial distribution and patterns of consumption across Malaysia. This not only highlights areas of high or low consumptions, but also helps in understanding regional differences. Overall, this project demonstrates the integration of desktop GIS analysis and web GIS visualization, showcasing how spatial data can be analyzed, interpreted, and presented effectively.
This map shows the share of non-domestic water consumption in Malaysia in 2028 for industrial, commercial, and institutional uses. The result indicates the more water consumption occurs on the west coast of Peninsular Malaysia, particularly around the Klang Valley, and this is shown by the darker color. This is typical of the urbanization, industrialization, and economic development in this region. By contrast, non-domestic water use in Sabah and Sarawak in East Malaysia is generally lower, indicating less concentrated in industrial development. Overall, the chart indicated that non-domestic water use is highly influenced by economic activity and urban development, with more developed regions requiring more water. Step 1. Visit the official website at QGIS. Download to access the open source mapping software. Step 2. Select and download the QGIS long-term release. Step 2. Select and download the QGIS long-term release installer to ensure a stable environment for your GIS project. Step 3. Execute the downloader installer to launch the QGIS setup wizard on your computer. Step 4. Follow the setup instruction by click next and accepting the term in the end user license agreement. Step 5. Choose your preferred destination folder and complete the installation process by clicking the finish button. Step 6. Launch the QGIS desktop application from your start menu and create a new empty project. Step 7. Add a foundational layer to your map by double-clicking OpenStreetMap under the XYZ tiles section in the browser panel. Step 8. Navigate and zoom into the map to focus specially on your chosen area of interest, such as Malaysia. Step 9. Download special data shapefile for your AOI from reliable sources like human data or GADM. Step 10. Import the spatial data into your project by dragging and dropping the file directly into the QGIS canvas. Step 11. Access the attribute table to manage spatial information and integrate external environmental data such as water consumption, non-domestic from data.gov.my. Step 12. Apply correlate map symbolic to visual represent different data value across your study area. Step 13. Ask the QGIS web plugin to export your desktop analyze into the interactive web GIS interface for digital sharing. Step 14. The next map is exported to a web format using the export to web map tool in QGIS.
Next, I will present the result of the comparison and evolution between the two platforms in Geographic Information System, namely Desktop GIS and Web GIS. We are often confused about which is better for our project. However, the choice actually depends on three main aspects. Among them are accessibility, searchability, and accessibility. Let's look at the main map one by one. The first aspect is accessibility. Desktop GIS is likened to a heavy system. The platform is very powerful for complex and in-depth analysis tasks. Therefore, it is often considered difficult for novice users. On the other hand, the WebGIS platform is designed with user-friendly principles. It is easy to use and interactive and allows anyone to explore data without requiring high technical skills. Next is the searchability aspect, which is how this system accommodates the growth of the number of users. The use of desktop GIS is quite limited because it is usually tied to only one person or one computer at a time. This makes it difficult to collaborate on a large scale. The main advantage of this web GIS platform is its nature that can be seen by many users. This means that data can be accessed by many pupils from different people via the internet network. The third aspect is accessibility. To use desktop GIS, we need specific software and certain computer hardware. It means PC. This means that its use depends entirely on the device that has the software installed. As for WebGIS, it offers much greater flexibility. Access via a browser is easy because users can access the information from any device as long as they have an internet connection. After we examine the previous aspect of use, now let's focus on the constraint faced by both platforms as well as the potential improvement that can be implemented to optimize the performance of our geographic information system. It means GIS. Each system has its own challenge. Of the constraints for the desktop GIS platform are that the first requires high computer specifications to operate smoothly, which this platform is less suitable for the second purpose of real-time collaborations. Third, because its licensing is expensive, for example, the ArcGIS desktop software. Next, the constraints for the WebGIS platform from a functional point of view, it has limited functional analysis when compared to the desktop version. Next, the system is completely dependent on the internet network. Without the internet, the system cannot function. In addition, there is a risk of the data security if the server configurations is not done correctly. To overcome this problem, improvement measures can be considered. For WebGIS, we need to add more advanced spatial analysis functions such as buffer, functions, and network analysis. Next, improve server performance to handle large data sets more efficiently. In addition, introduce offline mode for use without the internet. Finally, strengthen the security system through authentications and data encryption methods. For desktop GIS, we can integrate cloud technology to process large and heavy data. Second, introduce and provide a more user-friendly interface. Third, provide a lightweight version of light mode for ordinary user use. For WebGIS, we need to add more advanced spatial analysis functions such as buffer, functions, and network analysis. Next, improve server performance to handle large data sets more efficiently. In addition, introduce offline mode for use without the internet. Finally, strengthen the security system through authentications and data encryption methods.
For this slide, I will explain the digital skill we developed through the use of GIS in this project. First is data handling and management skills. In this project, we download both spatial and non-spatial data for online sources such as Spaceflight, KMZ, and CSV files. These data sets were imported into GIS software and managed by organizing map layers and handling attribute table. This key is important because it shows our ability to manage digital data correctly and systematically. Next is GIS software skill. We use GIS software such as QGIS by understanding interface and tools. We were able to add, remove, and manage map layer according to the needs of analysts. This demonstrate our technical competency in using GIS software effectively. Another key skill shown here is spatial analysis skill. We analyze spatial patterns such as a distribution of watercourses, classify data of correlations, mapping and understood the relationship between location and attribute data. This skill help us interpret spatial data in a meaningful way. Problem solving and critical thinking skill. We apply GIS to solve real environmental or spatial issue. We interrupted map result, explain our findings, and evaluated the limitation of the data and tools used. This reflects our ability to think critically and analytically. Next is map design and visualization skill. We created a clear and accurate map by applying a property symbology, colors, label, and legends. The production of correlates and thematic maps helps communicate spatial information effectively and clearly. And finally, we demonstrated WebGIS and publishing skill. We converted GIS map into WebGIS using QGIS web, created interactive web maps and share them through web platform. This skill is important because it allows spatial information to be accessed by a wider audience without requiring specialist GIS information.
Spatial analysis is used to map water consumption pattern across different areas such as urban, industrial and agricultural zones. It helps identify regions with high water demand and pressure on water research, which can lead to water scarcity. This information supports effective water research management, planning of water supply system and implementation of water conservation strategies. This map illustrates the distribution of water consumption across administrative area in Malaysia from 2018 to 2022, together with the location of industrial building, indicating that Selangor record the highest water consumption due to its high concentration of industrial area, while Perlis show the lowest water consumption, reflecting its limited industrial activities.
This project was successfully completed. We used Geographic Information System technology to map and analyze water consumption patterns across Malaysia from 2018 to 2022, showing that GIS is an effective tool for managing environmental resources and identifying areas with high water demand. The project applied a two-step GIS workflow. First, spatial analysis was conducted using desktop GIS through QGIS. Then, the results were converted into an interactive web GIS platform using the QGIS to Web plugin, allowing the findings to be easily shared and explored online. Through this project, we developed key GIS skills such as data management, spatial analysis, thematic and choropleth map design, and publishing interactive web maps. We also learned the strength and limitation of each platform. Desktop GIS is powerful for complex analysis but requires technical skills, while WebGIS improves accessibility and data sharing but has limited analysis function. Therefore, this project confirms that hybrid approach is most effective, where analysis is done in desktop GIS and results are shared through WebGIS. In conclusion, this project not only provides valuable insights into water consumptions in Malaysia, but also demonstrates the importance of integrating desktop and WebGIS to support better decision making.
That's
All
all
from us.
I think.
Thank you.